You are welcome to Math Demystified.
Equal sets. When do we say two sets are equal? What can we see before we can say that two different sets are equal? Now, two sets are equal if they contain the same elements, and that's all. Once you check a particular set A and check another set B, and they have the same set of elements, not number of elements, but the same set of elements, we say the sets are equal. Equal set is not the same thing as cardinality of a set. The cardinality of this set right now is 1, 2, 3, 4, 5, 6. 6. The cardinality of this set is 1, 2, 3, 4. 4. Do we understand that? But if you look at it critically, it's possible for them to be equal sets, even though the cardinality may not be the same. So please, I want you to note that when you are dealing with equal sets, all you are after is to check if the number of elements you have in a particular set is the same element, exact element you have in the other set. So look at this example. Example 3. If S, set of S equals B, A, D, C. They can rearrange this anyhow they want. B, A, D, C. Which of the following sets are equal to S? I look at this B, A, D, C. If I want to rearrange it to be A, B, C, D. Can you see that? So if I check any other set and I have A, B, C, D as the only set, only members of that set, then that will make the set to be equal to this S. Let me explain what I'm saying. This is a set S that has A, B, C, D as its elements. If I see any other set that all the elements in the set are A, B, C, D, and there is no additional elements added to the set, then that set will be equal to this set. Now, I want to note this from the beginning. This B may be repeated in any other set. This A may be repeated, D may be repeated, C may be repeated. Does not matter. As long as all the elements here are the same elements I have in the second set, the sets will be equal. Look at this A. P, set P has A, B, A, D, C, A, and D. And if you check set S, it has A, B, C, D. So let's check this set. There is A there, there is B, there is C, there is D. This is also A, this is also D. I don't have E, I don't have F, I don't have any other alphabet. I only have A, B, C, D. So this one is equal to S. Check the next one. There is A there, there is no B, there is C, there is D. This is out. So this is not. Even though it has 4 elements, this has 4 elements, but they are not equal, because one element is out, is wrong compared to the one you have over there. So look at this R. It said first 4 letters of the alphabet. And we know that these first 4 letters of the alphabet are A, B, C, and D. And every one of them qualifies. So this one too is equal. So we can therefore conclude that S is equal to P and S is also equal to R. But S is not equal to Q. Don't forget, you are free to pause the video and go over till you master it. Now we want to look at the difference between empty set and infinite set. From the word empty, that shows there's nothing inside. Infinite, that shows that you cannot exhaust it. You cannot finish listing those elements. So empty sets that have no element or member in them are called empty sets. And most of the time, the symbol we use for empty set is this and this without anything inside it, without any element. That shows an empty set. This is bracket we usually use, or you could just write 0 and cancel the 0 like this. So this symbol for empty set, this is also symbol for empty set. It is not ideal for you to write empty set like this. This set of empty sets does not make sense. And this one is not also equal. This is set of 0. So don't make the mistake of writing your empty set like that. So you can either write the empty set like this or write your empty set like this. One of the examples of an empty set is a square with 5 sides. It does not exist, so it's an empty set. Now, infinite sets that have never-ending list of members. You can never end it. When you start listing, you can never. Like when I ask you to list natural numbers, it's that 1, 2, 3, 4, 5. It is sweet when you're counting like that. By the time you get to 1 million, 2 million, you'll be tired. You can't finish listing. It has never-ending list of members. So those are, and we always use this symbol for that. Okay, so we have positive of the never-ending. We also have the negative of the never-ending. That's the normal way of writing infinite stuff. So that's positive infinite, negative infinite. Like when I ask you to write a list of negative integers, you can't finish it. You can't finish it. So that's the difference between empty set and infinite set. Very quickly, I want to explain the meaning of subsets. Subsets. Now, when you hear the word subset, it means that it's a smaller version of a bigger set. Subset. It's a smaller version of a bigger set. But one thing I want you to know is that a set is also a subset of a set. Then empty set is also a subset of any given set. Note those two things. Let's take this as an example. I have a set A that contains 1, 2, and 3. And I have another set B that has 2 and 3 in it. If I were to draw this now, I'll have something like this. This is my A that has 1, 2, and 3 in it. And I have another set B. You will see that the A contains B. The A has B in it. So, and you can also see that the A is bigger than the B. So when the A is bigger than the B, we say it's a proper subset. So we say B is a proper subset of A. That means that B can fit into A properly. Can you see? B can fit into A properly. So you can see that A is swallowing B. So B, and this is the symbol we use for subset. And we can change this symbol. When you change the symbol, you could read it like this, where the A is coming first. So the symbol will be the other way around. So in this case, you see that A contains B. That's the meaning of this symbol. A contains B. Okay, speak on subsets. If I ask you to list all the subsets, list all the subsets of A. Don't forget I said empty set is a subset of any given set. So I start with the empty set. Okay? And I can also make other sets, not having one element in them. They are all subsets. These ones are actually proper subsets because when I draw it like I did the other time, the A will swallow them. Then I can also begin to make them into twos. Say 1 and 2. I can also have another set that will have 1 and 3 in it. I have another one that will have 2 and 3. Then I can have the one that will contain all the 3. So these are all the subsets I can get from the first set. You see, empty set is one of them, and the set itself is one of them. So these ones are proper subsets because it can fit into the original set. The universal set is the original given set. It's the original given set. And we use this symbol, something like this, or to represent the universal set. It's like the universe. That is the original given set. Let's take, for example, if I say the universal set is a set of 1, 2, 3, 4. Then I have other subsets. Say 1, 3, and 4. If I have another one, D, something like 1, 2, like that. So this is the universal set, while these ones are the other sets taken from it most of the time. So definitely you will say these are subsets of the universal set. Union and intersection. From the word union, that means you are bringing the elements together. Intersection, what is common to them. So another way I want you to see union is combine. Then intersection, common. So for example, if I have a set A that is 1, 3, 8, and I have a set B that is 2, 3, 10. The union, the symbol for union is U. Symbol for union is U like this. And the symbol for intersection is like N like that. But it's not N, that's just symbol. So union, intersection. So if I ask you to give me A union B, A union B, you're going to, A union B. I'm going to bring everything together without repeating any element. So that will be 1, 2, 3, 8, and 10. To write every element, union, combine every element, but no repetition. Please note, no repetition. Now if I give you A intersection B, all I need is the common element. So if you look at these two sets, this is the only common element there, 3. And if there's nothing common, it becomes an empty set. So this union means combine. Intersection means what is common.
If you enjoyed our teaching, please click like and feel free to share our link with your friends. And do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.